Okay, in this problem we asked to determine the steady state voltage V0 SS of t in the network for t greater than 0 if the initial conditions of the network are 0. There's our circuit. You can see we have a cosine source, a sinusoidal input. Initial conditions are 0. So the way that we'll start off here is we'll need to draw the S-domain circuit and begin to do an analysis. We'll wind up doing a transfer function. So first, here's our S-domain circuit. And what we need to do is we need to go in and find the transfer function that relates V0 to VI. And we'll call that H of S. So to start off, let's first combine these impedances in parallel here, and I'm going to call this ZA of S. Okay, so ZA is S plus 2 times 1 over S plus 2 plus 1 over S. And after you go through and do the math, this becomes S plus 2 over S squared plus 2S plus 1. So now let's redraw the circuit. Here's VI, here's 1, here's S plus 2 over S squared plus 2S plus 1. I'm going to call this voltage V1 of S. So here's V1 of S in our circuit up there, the original S-domain circuit. So now V1 of S we can just calculate using voltage division. So V1 of S is S plus 2 over S squared plus 2S plus 1 over 1 plus S plus 2 over S squared plus 2S plus 1 times VI. So if we go through and work with the algebra sum, we can get this to V1 of S is S plus 2 over S squared plus 3S plus 3 times VI. And then if we go back to our circuit and again look at voltage division between V0 and V1, we can see from our circuit that V0 of S is 2 over S plus 2 times V1. So this is just from voltage division. Looking back at our circuit, so now V0 of S is 2 over S plus 2 times V1, okay, which is 2 over S plus 2 times S plus 2 over S squared plus 3S plus 3 times VI of S, and then obvious those two terms cancel out. So now we're left with V0 of S is 2 over S squared plus 3S plus 3 times VI. And now here is H of S. So now we've got H of S. So now remember that VI of t is 12 cosine 2t U of t volts. So the peak value of our cosine wave is 12 volts. The frequency is 2 radians per second. So now let's go in and take H and evaluate at S equal J2. So we have 2 and we have divided by J2 squared plus 3 times J2 plus 3. And as we calculate that, this is 0.3288 at an angle of minus 99.46 degrees. So then V0 SS of t is 12 times 0.3288 times the cosine of 2t minus 99.46 degrees. So this is 3.95 cosine 2t minus 99.46 degrees volts.